Hello everyone. Um, Today I'm going to talk about chapter 4, Similarity. In this chapter, I'm going to share with you how we can prove two triangles are similar and what are the conditions for similarity between two triangles. Without further ado, let's go to the next page. So over here I have two triangles already. Before I proceed, let me label these two triangles first. Okay, over here you have your triangle ABC and your triangle EFG. Okay. By the way, you can actually call your triangle ABC triangle BCA as well. Okay. All right. So, uh, when you call your when you name your triangle, okay, when you name your triangle, so you can also call your you can also name your triangle CAB. Okay? When you name your triangle, right, the order of the letters is not very important. Okay, the order of the letters here is not very important. Okay. So when you name your triangle, you can actually pick one of these, okay, to name this triangle ABC or BCA or CAB. Okay, it doesn't matter when it comes to the order of the letter. Okay. Right now, so we are talking about what are the conditions to prove similarity between the two triangles, right? So let me continue. Okay. So when you need to prove two triangles are similar, so the order of the letters to name your triangles is important. Okay, when you need to prove two triangles are similar, the order of the letters you choose to name the triangles is very important. Okay, so what I mean by that, okay, over here you have your this triangle and this triangle. Okay, so what you need to do is, before you want to prove these two triangles are similar, so what you need to do is you need to match. Okay, you need to match point to point. So I hope you can see your A actually matches to your point E here of the other triangle, and then your point B here, okay, it matches the point F of the other triangle. And last but not least, your point C here, it matches the point G of this triangle. Okay, so the order of letters you choose to name your triangle ABC, you should match this triangle ABC with. So now we are proving two triangles are similar, right? So if I pick triangle ABC, so I have to pick what? Triangle. Similarly, you start with ABC, so you also need to use EFG. So they are similar, right? So it's similar EFG. Okay, so when it comes to proving two triangles are similar, the order of the letters you choose to name the triangle is very important. Okay, so this is one very key concept. Okay, so the conditions to prove these two triangles are similar is this angle A must be equal to your angle E, and similarly, you actually write down angle here. So similarly, your angle C must be equal to your angle. Okay, your angle B must be equal to your angle F. So therefore, your this triangle ABC is similar to your triangle FG. Okay, and you are actually using your A. Okay, I hope you can see. Okay, so very simple. So I'm going to use another example to illustrate this concept again. Let me go to the next slide. So over here you have two triangles, okay, and what you can do is, like I say, what I need to first do is I need to label, okay. So let's call this ABC, and let's call this EFG, okay. So what you need to do first is you need to match, okay, you need to match point to point between two triangles, okay. So if you call this triangle ABC, okay, what you need to do is you also need to call this triangle your GFE, okay. I hope you can see your point A, it matches with your point G here, okay, and then your point B here of this triangle, it matches the point F this triangle, okay. So therefore you want to prove the triangles similar. What you need to do is you need to make sure your angle A equal to your angle G, and then your angle B is equal to your angle F, and your angle C is equal to your angle. All right, so you are using what? You are using A here, okay. So in fact, right, in fact what you should do is you should write down your these conditions first, okay. Write down these conditions first, and then what you do is your conclusion should come after your this, okay. Your conclusion should come after your this um, conclusion should come after these conditions. So whatever you have here, so let me get rid of this. So whatever you have here, erase it, okay. So remember this, remember the flow of your these solutions, okay. The flow is first start off with the conditions first, okay, and then write your statements next, okay. And when you write your statements here, make sure um your this triangle and your this triangle, okay, they are matching each other point to point, okay. Like your A should match with your G, and then your B should match with your F, and then your C should match with your E, okay. All right, so okay, last but not least, I'm going to use the last example to illustrate this concept and see what are the problems um, you may encounter, okay. So before I'm going to solve this, I'm going to label this diagram first. So let's call this ABC F, okay. And let me write down some of the conditions here. So your FD is actually parallel to your this AB, okay. By the way, this is a parallel sign, parallel, okay. So I hope you remember what are the three rules, um, what are the three rules you can use when it comes to parallel lines, okay. So if you can't, let me just write them here. So if you have this, let's say this and this, they're parallel, and you can actually have these three rules, okay. So I hope you can see this is your Z. Okay, this is your F, and then this is your C. Okay, and for each of them, by the way, yeah, so this and this, they are parallel to each other, and this they are parallel, this and this they are parallel. So um with with them parallel, then only you can use your this rules here. So over here, your this angle and this angle, they are equal. So let me label these two angles, 1 and 2, 1 and 2, 1 and 2. Okay, so your this angle 1 is actually equals to angle 2. Okay, and you are using alternate angle. Okay, if you have forgotten this rule, you can actually refer to my previous video. Okay, it's under chapter 4, congruence. Okay, so refer, if you have forgotten these above rules, you actually refer to my chapter 4, congruence. Okay, congruence video for these three rules. Okay, so over here, angle 1 is equal to angle 2, and you are using corresponding angle. Okay, over here I'm using short form. Yeah, so angle 1 plus angle 2 add up to 180 for this. So you're actually using internal angle. Okay, so like I say, if you have forgotten this, or you want to have a better understanding of these three rules, you can actually refer to my this chapter 4 congruence video for um more information. Okay, okay, over here let's come back to this question. Okay, so over here your FD is actually parallel to your AD. I mean FD is parallel to your AB. Okay, which is, this is parallel to this. Okay, so if these two are parallel, what you can notice is your this angle is actually equal to this angle. Okay, I'm using alternate angle here. So angle F is equal to angle B. The reason is alternate angle. Okay, I hope you can see your Z here. Okay, this is your Z, which is your alternate angle rule. Okay, let me place this first. Okay, all right. So next, okay, I hope you can see your this angle is actually equal to this angle as well. Okay, the reason is alternate angle, right? So angle D is also equal to angle A using alternate angle as well. Okay, so this is your Z once again. Okay, so yeah, next. So therefore, your this angle, this angle FCD is here, is actually equal to this angle as well. So your angle FCD equal to your angle ECA. Okay, using, okay, so if you have all these angles, okay, you have few of them and they are equal, so you can actually conclude your your triangle ACB and your triangle. So your A here, it matches with the D here. Okay, so therefore this triangle ABC is actually similar to your triangle um, DCF. Okay, all right. Okay, so with these two triangles, they are similar. So let's continue with this example. So if you have, or you are given your FC is equals to 2 cm, then your BC is equal to X cm, which is not known, which you need to find but you are given this is 3 cm, and over here, okay, this is not 3 cm. Okay, let me choose another. Okay, so over here is 4 cm, and then over here is 2.5 cm. Okay, another reason, the reason I choose 4 here is, um I don't want to choose 3 here. Okay, because if your x is 3 later and over here is 3, so your this triangle ACB is an isosceles triangle, and this is not the case here. So that's why I want to choose 4 cm here. Okay, but anyway, so let's look at how we can make use of the similarity between the two triangles and solve for our x. Okay, so if these two triangles are similar, so the ratio, the length ratio, so if they are similar, the length ratio between two triangles between two triangles, okay, remains the same. Okay, so let me write this more clearly. So let me repeat this once again. So if these two triangles are similar, the length ratio between these two triangles remains the same. Okay, what do I mean by that? Okay, so you should know this triangle ABC. Okay, it matches with your triangle DCF, right? So DC, CF. So CF. Okay. So what I mean by this statement is length ratio between the two triangles remains the same. What I mean is your this AC over your this DC is equal to your CB over your CF, and which is also equal to your BA over your FD. Okay, I hope you can see, if your point uh, match already, so your sides AC, it matches the side DC here, and your side CB here, it matches your CF here, and last but not least, your BA, it matches your FD here. So therefore, the length ratio between the two triangles remains the same. Okay, so with this, you can actually go and figure out what's your x. Your FC is 2, right? Can you see your FC is here? So you can actually make use of this. FC is 2 cm, but you just need to write 2. And your CB is not known, so CB is not known, so it's x. And what else do you have? Your AB is 4. Okay, so your AB is 4, or BA is 4. Okay, and your FD, okay, your FD is 2.5. So let's replace with 2. And you just need this side of the this side of the equation, so you can actually figure out your x, right? So you do your cross multiplication. Okay, you do your cross multiplication, and the left hand side is 2.5x equal to 2 times 4 is 8. So your x is equal to, so your x is actually equal to 8 divided by your 0.5. Okay, actually do it this way. 8 divided by 2.5, which is divided by 5 over 2 is times 2 over 5. So you get what? You get 16 over 5. So 16 over 5 is 3.2. Okay, so your x, the value of your x is 3.2. Okay, so you have used similar triangle properties, which is length ratio between the two triangles remains the same, so you can actually figure out your value of x. Okay, so with this example, I have finished the concepts you need to grasp this chapter. So okay, before I end the video, I hope you can subscribe to my channel on YouTube under this name. Okay, okay, YOUKANG, and with a space here, LU. Okay, and if you manage to watch this video, okay, you can actually subscribe just below this video. Okay, I think you are tech savvy enough to know how to subscribe to my this video. Okay, thank you for watching. Bye.